Assalamu alaikum, welcome back everyone to chapter 3.1 of the Arduino series. In this video we're going to cover LDR and potential dividers. Now to start off, I'm going to talk about the effects of changing the LDR, the light dependent resistor's position on the circuit, whether you make it the first resistor or the second resistor, what it does to the circuit's voltage and what it does to the circuit's resistance. Now for this video we're going to need an Arduino breadboard, 5 wires, both ends male. We're going to need a light dependent resistor, we're going to need a resistor, 330 ohm is the one that I'm using, and an LED of any color. Now your circuit's going to take this format. To begin with, you want to take the red wire or the power wire, the dedicated power wire, and plug it to the 5 volts. You can also plug it to the 3.3, however the 5 has a stronger and more visible effect. You want to take the power and connect it to one of the resistors. I've chosen to begin with the 330 ohm resistor. Next, you want to connect the LDR, any one of its legs, to the end of the resistor. In the same column, you also want to plug in 2 wires. I've chosen yellow and I've chosen white. At the end of the LDR or at the end of the resistor that you've chosen, you want to get a black wire or any wire and ground it. A little bit to the left, I've used my LED, I plugged it in. You just want to make sure that it's plugged correctly. The short end is going to be the one that's grounded, so I've used a black wire for that one. I've taken the yellow LED that I've plugged in the same column with the end of the resistor and the start of the LDR. I've plugged it into the long leg of the LED. I've taken the white wire into the dedicated analog input pins of the Arduino and plugged it into A1. Now before I go into the different arrangements of the LDR, we have to understand what a potential divider is. A potential divider, also known as a voltage divider, is achieved when you have 2 resistors in series. There's a formula to calculate voltage out, which is what we're going to use throughout the 2 arrangements, which equals to voltage in multiplied by R2 divided by R1. Now in our first arrangement, we have the LDR as R2, and when you replace it into the formula, it is what I present to you right now. Now we know the voltage in is 5 volts because the Arduino supplies a constant voltage of 5 volts. Now, if you were to simplify the formula furthermore, you're going to find out that on the numerator we have the LDR, which is 4 times the value of the resistance that it provides, and divide by R1, in our case it's 330 ohm. And for the fact that our LDR multiplied by 4 is on the numerator, we know that the relationship between the voltage out and the numerator, the 4 times the LDR, is directly proportionate. So if we were to increase the resistance of the LDR by shining less light, the voltage out would increase. And if you were to shine light onto the LDR and decrease the resistance, the voltage out would then decrease. Now in our second arrangement, we have the LDR as R1 and our 330 ohm resistor as R2. And if you were to substitute everything into the formula, it looks like this, where voltage out is equal to 1650 ohms divided by the resistance of the LDR plus 330 ohm. And since the value of the LDR is on the denominator, the bottom of the fraction, we know that the relationship between the voltage out and the LDR is inversely proportional. So if you were to shine light and decrease the resistance, the voltage out would increase. If you were to prevent any light being shone onto the surface of the LDR, the resistance would increase and the voltage out would decrease. The LED would decrease in brightness. Now in order for us to understand how the circuit is laid out, we're going to go through the diagram again and consider that we have our LED that's on the circuit in this portion of the diagram. Now the LED's job is to measure the value of the voltage output. So the higher the voltage output, the brighter it lights up. However, we have to understand that it has to be connected in parallel to the rest of the circuit. So these 2 resistors are connected in series. The LED is connected in parallel to the circuit. Consider this portion here, the yellow wire, and this portion here, the black wire, is connected to the ground. Now since our code is very basic and the circuit in itself is not very complex, doesn't use too many components, the code is very short. For the variables we only use 2. The first one being the resistance, which I later defined, and the second one is D time, which I use for the delay time, which I use in the delay command, which equals to 250 milliseconds or 0.25 of a second. In our void setup, I have pin mode A1, which is the dedicated analog input pins, and I told the Arduino this pin is going to be an input. Next, I told the Arduino that I want to activate the serial monitor using this command, the serial.begin, using the baud rate 9600. In our void loop, I came down and defined what the resistance is going to be. I told the Arduino I want to read the analog value from the A1 pin using this command over here. Next, I went down and I used the serial.println command to tell the Arduino I want to print the variable that I just defined, and between every single time it prints the resistance value, I want a delay of 1/4 of a second until the next one is printed. Now if I was to go and open up my serial monitor, we can see that there's a value given. This value is proportionate to the value of the 5 volts. So the highest value that the Arduino can give is 1023. So 1023 is 5 volts. 23 is, you can say that maybe it's 1.5 volts. However, I have my LDR as the first resistor, so if I was to cover the LDR with my finger, the voltage would decrease to 75, somewhat constant. However, if I was to apply light, you'd see that the voltage increases and the LED increases in brightness. If the video helped you out in any way, consider giving it a like, and if you wish to get closer to the community that I'm trying to build, there's going to be a Discord link in the description where you can also find the code to this video.